So in this lesson, we're going to be covering division. So division is just the opposite of multiplication. So a simple example, we might say 3 times 4 is 12, or 3 lots of 4 is 12. But we can ask this question in reverse. And we can say, what is 12 divided by 4? And here we're asking how many multiples of 4 fit into 12? Well, exactly 3 lots. But what happens when we have larger numbers outside of our standard mental arithmetic sets of numbers, the 1 to 9? Let's take the example of 246 divided by 2. So we need to lay this out in a long division format, because these numbers are too big to do it with. So the format will look like this. Where we write down on the left here the number that we're dividing by, our divisor, and inside of this working out is the divisor, what we're dividing. And what we're going to do, we're going to split this into two. I'm going to draw out here a line to separate our answers from our workspace. So what we do, line by line, or column by column, we look at each individual number and see how many multiples of 2 fit into it. So in this case, bring down the 2. So when we ask ourselves, how many multiples of 2 fit into 2? In this case, there's nothing left over, it's exactly 1. So 1 goes up here in our answer space, and we take away the 2 from 2, which leaves us with 0. Then we move on to the next column, number 4, and we ask, how many multiples of 2 fit into 4? In this case, 2 lots of 2 fit into 4. So 2 goes up here. And what we need to have done, which won't be so bad for this question because everything fits in neatly, but later on become important, is the 4 gets brought down here from our question. And we know that 2 lots of 2 was 4, so 4 minus 4 is also 0. That's where we get the 0 remainder from. And then bring 6 down from our question to our workspace here. This will become more clear why we're doing this each time later on. How many 2's fit into 6? 3 multiples of 2 fit into 6. So take away 6 from that, and you're left with 0 remainder, and there's our answer, 123. Now, this looked a bit of a clunky at first, but this is because 2 fit into each of the numbers 2, 4, and 6 quite neatly. But there are questions where this isn't going to be quite so simple. Let's take the example of 372 divided by 3. So I'm going to lay this out again in long division form. 3, 7. So again, we start with our first column and we lay out our workspace. So we bring the 3 down from our question, or from our target number. So how many 3's fit into 3? Exactly 1. So 1 goes up here, and we put the 3 down here because it's 1 times 3 is 3. That leaves us with 0. Now we bring the next column down, 7. How many 3's fit into 7? Well, this is a bit more tricky now because 3 doesn't neatly go into 7 at all. If you think of our 3 times table, 3, 6, 9, 12. I won't go any further for this example. We can see that 7 fits awkwardly right here. So we can fit in 2 times 3, but we're going to have 1 remainder. So this is where the layout for this method happens. So we know the biggest multiple of 3 we can fit in was 2 lots of 3. So in our answer space, we put 2, and 2 times 3 was 6. So when we do the subtraction now, 7 minus 6 is 1. So that was 1 left over from this column. So when we go to work out the next column, when we bring our 2 down, we have to include the 1 that was left over from the previous column. So now we ask how many 3's fit into 12. In this case, 3 fits in exactly 4 times. 3 4 is 12. And that should leave us with 0 remainder. And that's the answer. 372 divided by 3 is 124. So the next question is, what happens when there's still a remainder at the end of this question? So let's do 253 divided by 2. So we follow the same format again. In our first column, 2 fits into 2 precisely 2 times. So 2 fits into 2 precisely once. So bring this, so it's the 2 in the question that gets brought down first, and then it's 1 times 2 was 2, and then you calculate your remainder to be 0. You take them away from each other. So that's those are the hundreds columns. Now we're going to the tens. Bring the 5 down. How many 2's fit into the number 5? Well, as we said in the previous example, 2 lots fit in. That's 2 times 2 is 4. And we can't fit 3 lots in. So the largest multiple of 2 that fits into 5 was 4. Do the subtraction, 5 minus 4 is 1. Then we move over to the next column, 3, bring that down. How many 2's fit into 13? Well, the largest that fits in is 12, which was 6 times 2. And that's going to give us a remainder of 1. So in primary school, you would have left this as 126, remainder 1. But remainder 1 is not really that useful in maths. It doesn't have a very good meaning at all. So instead, we're going to carry on. So what we have to remember is this 253 actually contains hidden zeros after the decimal point. But this allows us to continue on with the question. So we can bring this 0 down here, and we keep going. How many 2's fit into 10? Precisely, 5 lots of them do. Remembering the decimal point, because we've now moved in the decimal point here. Your answer and your target number should always line up with each other, so the decimal point should say the same vertical orientation. So 2 fits into 10 5 times, and that gives us 0, which might have just come off the camera there. And there you go, there's our answer. So this question answered neatly because it finished with 5 with no remainder. But sometimes you can get decimal answers which carry on. Quick example is 8 divided by 3. So in the case of 8 divided by 3, how many times? Always try to remember the same pattern here. Bring 8 down to the workspace. 3's fit into 8. Well, the largest multiple of 3 is going to be 6, which is 2 lots of 3. That leaves you 2 remainder. So now remembering 8 is 8.0. It's a good habit to put the decimal point in first before you go any further. Otherwise, if you get it at the end, you're likely to make a mistake. So now bring our 0 down. How many 3's divided into 20? Then we're going to get 8 lots. No, sorry. 6 lots. So 6 3's were 18. So that leaves us with 2 remainder in this column. Same thing applies. Add another 0 on after the decimal place, and we carry on. How many 3's fit into 20? Again, 18 will, with 2 remainder. So 6 3's are 18 with 2 remainder. But you can start to see the pattern here that keeps reoccurring. We're always left with 2 remainder each time. So this answer, 2.6, will just carry on forever. So what we do in this case, when there's a pattern that's repeating, we truncate the answer down to the first point of repetition, and we put a dot over that answer. So 2.666 recurring is just 2.6 with a small dot over the top. So how do we deal with larger divisors that aren't just single digit, such as 253 divided by 2? What happens if we have this example, 250 divided by 12? Exactly the same principle, and exactly the same workings out. Except now we're asking how many models will 12 fit in rather than single digits like 3 or 2. So bring the 2 down into our workspace. And we ask how many 12's fit into 2. Now it looks a bit odd because 12 is bigger than 2. But that shouldn't be a problem because 0 fits in, or 0 multiples of 12. Think of this as 12 times 0 is 0. That's the first step in your 12 times table. So you can say, well, 0 lots of 12 fits in. So 0 goes up here. 12 zeros is 0. 2 minus 0 gives us 0. Also, 2 minus 0 gives us 2, where we started. So that's finished that first column, and now we bring the second column down, bring the 5 down. How many 12s fit into 25? This is where it's handy if you don't feel comfortable with mental arithmetic. Just write down your 12 times table. So 0, 12, 24, 36, and work this off to the side. And then you can just look back here at your workspace to then figure out which is the answer you need. So 25 is, we can fit 1 times 12, 2 times 12, 3 times 12 is too big. So the answer is 2 lots of 12, put the 2 up here. 2 lots of 12 is 24. That gives us 1 remainder. So bring our 0 down. What's the largest multiple of 12 that fits into 10? Well, 12 is too big, which is 1 times 12, so again it's 0. 0 12 is 0, bring the 0 down. That still leaves us with 10. Obviously we've got remainder still, we have a 10 remainder whilst we finish with our question, so we have to add in zeros at the end of it. Then we can bring the 0 down, and then carry on. And you repeat this until you have your final answer. Fortunately, I think I ran out of space at the bottom here. But if we carried on, then we would have 12 into 100. Just keep counting out in our 12 times multiplication here. So 36 goes to 48, 60, 72, 84, 96, and 108. 108. So the largest multiple that fitted in was 1, 2, 3, 4, 5, 6, 7, 8. So it was 8 lots and 96. And this is going to give us an answer which doesn't end, it keeps carrying on. So we'll leave this at 1 decimal place for now. So chance for you to practice the question. 3,178 divided by 7. Give the video a pause, and then carry on and we'll look at the answer. So, the answer to the question. First of all, bring the 3 down. How many 7s fit into 3? Well, 7 is bigger than 3, so no lots of 7 in this case. So, 3 minus 0 is going to be 3. So, for the next column, bring 1 down, gives us 31. How many 7s fit into 31? So if you're not comfortable, just again, you have white space on the outside of your paper for a reason. So just write down your 7 times table. So 0, 7, 14, 21, 28, 35. You can see, so 0, 1, 2, 3, 4. 4 7s is the largest multiples that you can fit into 31, which is 28. So we put 4 up here, because that was the largest multiple we got up to. 38 minus 21. So give us 3. So for the next column, bring the 7 down. Now we ask, what's the largest multiple of 7 that fits into 37? In this case, it's 5 lots at 35. So 5 lots at the top. And we put 35 down here. That gives a remainder of 2. Then we bring the 8 down. How many 7s fit into 28? In this case, it gives us a nice easy answer. Exactly 20. Because there's a nice clean answer, which is 4 7s are 28, which will give us 0 remainder. And that's your answer. So far with division, all we've covered is dividing by whole numbers. And we have to ask the question, what happens when we have decimals thrown into the mix? So let's take an example of 12.5 divided by 2. So long division only works if the number you are dividing, the target number, can only work if that's the decimal. If your divisor is a decimal, then this method won't work and you need to then use a lot of fraction manipulation, which will be covered in a separate video. So in the case where the number we're dividing is the decimal, the method works exactly the same as it did before. because you've got the decimal, you might as well put the decimal in your answer line ahead of time. So, and then we just carry on as we did before. So bring the 1 down. How many 2's fit into 1? None in this case, because 2 is bigger than 1. So 0 lots of 2 is 0. Do take away, that still leaves us with 1 remainder. Now we bring the 2 down. How many 2's fit into 12? Exactly 6 lots 2. 6 2's are 12. So we do the takeaway, that leaves nothing remainder. Bring the 5 down on the question. How many 2's fit into 5? 2 lots. 2 2's are 4. You do the takeaway there. That leaves us with 1 remainder. So after the 5, we just put another 0 afterwards. Now we bring that 0 down. So that gives us 10. How many 2's fit into 10? Exactly 5 lots, because 2 5's are 10.